Hello everyone. Previously we had discussed on the rolling hash algorithm, right? Also known as polynomial hash algorithm, right? So today we'll be discussing on the edit distance using Wagner-Fischer algorithm, right? So also known as edit distance algo, right? So this one, let's get into the definition part directly. So edit distance is the minimum number of operations. See here, whether it may be insert, delete, replace, right? So that is required to convert one string into another. Again, edit distance is the minimum number of operations, whether it may be insert, delete, replace, required to convert the one string into another. So the Wagner-Fischer algorithm solves this using the dynamic programming and pico of m into n time. Again, the Wagner-Fischer algorithm solves this using dynamic programming and pico of m into n time, right? So let's get into the this one explanation part. So just listen to this carefully. So the same thing will be implementing in the form of algorithm or the code, right? So here suppose we want to transform string word1 into word2, right? Suppose we have a string word1, we want to transform that one to the word2, right? So allowed operations are it may be either insert, delete or the replace, these three things. So we will be making use of the DP table for that, right? So DP of ij equals minimum operations to convert first I characters of word1 into the first j characters of word2, right? So we will go with the go on filling the base cases first. So if one string is empty, then if one string is empty, then what we need to do? Either we have to go with the insertions or the deletions, right? So transition is if the characters match, no operation is needed. Otherwise, we'll be going with 1 plus minimum of insert, delete or the replace. The exact same thing. Let's try to articulate in the form of code, right? So now first thing what we'll be doing, let's go with this one, what do we call function. So I'll just go with edit distance, this one function. So we have to have two strings, right? I'll just go with s1 and s2 for this one. This is fine. Now let's do one thing. Let's initialize the DP table of the size m plus 1 into n plus 1, meaning, so I'll just go with here this one 0 into this one, what I said, n plus 1 into this one, right? M plus 1 into n plus 1, right? So I'll just go with 0 into n plus 1. This one for let me leave space here, sorry, yeah, in range. So this one we have to consider m plus 1. This is fine. Now we are done with the first step, right? So we are done with the first step. Next what we will be doing, so we have to initialize the DP table of size m plus 1 into n plus 1. Now let's go with the base cases as we discussed here. So what is the base case here? So somewhere we have to fill the base cases, right? If one string is empty, then we need insertions or the deletions, right? So let's go with the same thing. Why this is showing like this actually? Just give me a second here. Oh, didn't I? Oh yeah, so just give me a second here. We have to go with the lengths of the two strings. I forgot that one completely, man. Sorry. I'll just go with here m comma n, that is equivalent to this one. M equals length of s1 and n equals length of string s2. This is fine. Now let's go with we have went with the DP as well. We have initialized the DP table of size m plus 1 and n plus 1. This is fine. Now let's go with the base cases. So this one for I n range, so this one is m plus 1. Then what we will do, let me go with DP of I 0 equals I, meaning, so we are converting s1 of 0 to I to the empty string that needs I deletions. This is fine. Next let's go with the one more for loop here for j n range. This time I'll just go with n plus 1, right? So previously we went with m plus 1, this time we'll be going with a n plus 1. So now we have to convert the empty string to s2 of 0 to j, right? From not previously we had went with converting s1 from 0 to I to empty string that needs I deletions. Now we'll be converting empty string to s2 of 0 to j that needs j insertions, basically not the deletions, j insertions, right? So this one will be dp of 0 j, this is equivalent to j. This is fine. Now let's do one thing. Let's quickly fill the DP table, man. Yeah, let's quickly fill the DP table. So this one is for I and range 1 comma m plus 1. This is fine. The next step would be, I'll just go with one more for loop here for j in range. So this one will be 1 comma n plus 1. This is also fine. Now let's go with a simple if condition. If this one Python, right? So this one has to be s1 of I minus 1 is equivalent to string 2 of this one, j minus 1. Simple. Now if the characters match, then extra cost is not needed, right? So no need of the extra cost if the characters match. So I'll just go with dp of ij equals dp of I minus 1 into j minus 1. This is enough, right? Else what we need to do, if the character doesn't match, then so we have to go with the either insertion, deletion or the replacement, these three things, right? So this is simple, man. So this one will be dp of I j equals 1 plus mun of so sorry, this one has to be dp of I minus 1. Just give me a second here. This is fine, man. dp of I minus 1 j. So this is for the deletion. Next let's go with the insertion. dp of I into j minus 1. This is also fine. Now or we can go with the replacement as well, right? So this one will be dp of I minus 1 into j minus 1. This is for the replacement. This is fine. We are done with the insertion, deletion, insertion as well as the replacement accordingly. Now we are left with only one thing, that is we have to go with the final answer in the bottom right cell, the last one. DP table, mostly all the times the answer is present in the last bottom right cell, right, and the DP table. Now what we have to do, so just give me a second here. So let me go with return here. So this one has to be, what we need to return, m and n, right? So this one will be m and n. So now this is it for the algorithm, right? So let's go with the example usage, right? So I'll just come here very quickly. So let me go with word 1. Let me go with kitten here, nothing. So I'll just go with kitten. Swanny. Let me go with word 2 here. So I'll just go with sitting. This is fine. Let's go with the result here. So this one, let me pass the function name edit. This one I have misspelled here, so let me remove this one here as well. Edit distance of, let me pass word 1 and word 2. So I'll just go with word 1, yeah, word 1 comma word 2. So this is fine. Now let's print something for the interactive purpose. So I'll just go with print. So here I'll just give edit distance between. So I'll just go with here let me pass word 1 here. So this one, and also let me pass word 2 here. This is also fine. Now let me go with is. Let me pass result. This is also fine. Now we are done with the coding part. Also I have included the example usage here as well, right? So let me explain whatever we have done so far, and just then after that we can run the code, right? So here m comma n, whatever I have written, this one line number 31. So see here, so this is nothing but the length of the input strings, we know, right? So dp of 0 into n plus 1, this one whatever I have written, this one I have already explained. This is nothing but we are just creating the dp table with a extra row or column for the empty prefix, right? So the first loop here, whatever I have used for I in the range, this one in the line number 35. So this is nothing but the cost of deleting all the characters to make empty. What would be the second one here? Second one, so this one will be dp of 0j equals j. So this is nothing but the cost of inserting all the characters to build target string, right? So this is also fine. Let's come to line number 40, nothing but nested loop, right? So if s1 of I minus 1 equals s2 of j minus 1, whatever I have written, so this one no operation is needed right here, so we'll just copy the diagonal value, right? So if because here if the characters match, then no operations is needed, we'll just copy the diagonal value directly, else we have to take the minimum of this one. So this is nothing but the deletion, this is nothing but the insertion, line number 47 deletion, 48 insertion, and finally this one 49 is nothing but the replace, right? Replacing. So finally we are returning dp of mn, nothing but final edit distance, right? So this is it for the algorithm, right? So let's try to run. So what output that we need to get here is we are replacing, see here we have kitten and sitting, right? So we are considering word 1 kitten and word 2 sitting. So edit distance between kitten and sitting is 3. Edit distance between kitten and sitting is 3. See here, just give me a second, I'll show you very quickly. So we have considered here this one kitten, and we have considered this one sitting, right, for the example. So I have just given here what we have considered sitting, right? Yeah, sitting. 1 second, this one, right? So now first what we will do, kitten, we will be replacing k with s. We will be replacing k with s, right? So when we replace k by s, so we are basically we are going with this word, right? So what we are trying to do here, we are trying to replace k with s. So this becomes kitten becomes sitten, right? Kitten becomes sitten, right? So this is fine. Now what we will do, we will replace e with i. E with i, we have replaced k with s. Now we will replace e, this one, e with what we will replace e with, we'll replace e with I basically. So we'll replace e by I, k we replace with s, e will replace this one by I. Now the sitten becomes si double t in, right? So this is fine. Now finally what we will do, we will insert g. So this is sitten, and now if we give sitting, if we insert g at the last, so this one will be from sitten to sitting. So finally we have got the word sitting, this word sitting, right? So how many operations? So first one is we replaced k with s, so we replaced e with I, and finally we added here g. We added g here. Total 3 operations, right? So total 3 operations. So this is fine, very simple, right? So total 3 operations. So this 3 we have to get this one as output. Edit distance between kitten and sitting is 3. So if we have written the algorithm, we will get the correct output, right? So let's see the same. Now if we have written the algorithm correctly, then we have to get the correct output, right? So I'll just go with Control J here. Let me, yeah. So now I'll just give here Python. This one is fine. Let me go with 18 here. This is fine. Rename. Yeah, copy this one. .py. So we have invalid syntax. Perhaps you forgot a comma. Where is this? Yeah, for line number 33, man. Just give me a second here. So let me leave space here. So this one, yeah. Now we are getting the correct. This one I forgot to give space here. Basically, now we are getting this one. Edit distance between kitten and sitting is 3. Right? Simple. I have shown you all the 3 operations that is required. Right? So 3 operations are required to convert kitten into sitting. Right? So this is it for the edit distance algorithm. Very simple, right? So this is basically, it is known as Wagner-Fischer DP, right? So this edit distance is solved by Wagner-Fischer algorithm using that DP, right? Simple, right? So we are done with the edit distance, also known as Wagner-Fischer DP algorithm, right? So now let me summarize whatever we have learned so far. Just try to remember these points, man, right? So edit distance measures how different 2 strings are. First thing, right? Edit distance measures how different 2 strings are. Second one is Wagner-Fischer DP algorithm builds a matrix of subproblems. This is very important, right? So this is very important, right? So basically it is completely dependent on the DP itself. Wagner-Fischer DP algorithm builds a matrix of subproblems. Each cell represents the minimum operations up to that prefix, right? So final answer, we know it lies at the bottom right cell as usual, as we are building the DP table. So overall time complexity would be big of m into n, and the space complexity would be big of m into n as well. The time and space complexity for this particular algorithm would be big of m into n, right? So it will be fun to implement this one in the contest, or any contest, right? NACP contest, or any this one LeetCode contest basically. So this is it for the edit distance algorithm, right? So next will be this one. So next we'll be discussing on the sorting algorithms, different sorting algorithms. We'll be starting with the merge, merge sort, right? So let's finish it off. So these are some of the very important string based algorithms, man. So we have 10 algorithms here. So this will be very helpful if you know. I'm not gonna say that you have to mug up everything. Just listen to this and you have to know when and where to implement, right? So whenever it will be very helpful when you are implementing certain things in the contest, right? Basically, if you know the algorithms pretty well, you can just implement anywhere, wherever you want, right? So you have to know where and when to implement. That's it basically. So these are some of the very important 10 string based algorithms, right? So we started with KMP, then we went with Robin Corp basically, then this one Z algo, then Manish's algorithm as well. So we discussed suffix array construction along with this one, I believe. Just give me a second here. Yeah, this one, what do we call? Suffix array construction along with the Casais algorithm, right? With the help of this one Casais algorithm. Then we went with a suffix automaton. Then we went with Aho-Karasek algorithm. Then previously we discussed this one, try algorithm and rolling hash, or the polynomial hash algorithm. Finally, we are finishing it off this one. What do we call? String based algorithms with the edit distance algorithm, also known as this one, Wagner-Fischer DP algo, right? So as I have said, next we'll be discussing the sorting algorithms. First we'll be starting with a merge sort. For now, this is it. Thanks for watching, guys.